Welcome to the last portion of Chapter 3, the Biological Psychology, the Brain at Work. Let's go ahead and get started with Section 3.4, and we'll finish off with Section 3.5 as well. 3.4 Objectives. Summarize the primary functions of both the CNS, the central nervous system, and the subsystems of the PNS, the peripheral nervous system. Explain how the electrical components of the nervous system and the chemical components of the endocrine system work together to influence behavior. All right, so let's look at the functional divisions of the nervous system. All right, so the nervous system is divided into two main parts, and that's based on function: the central nervous system and the peripheral nervous system, CNS and the PNS. Each of these has its own subdivision and specific roles. So the central nervous system, for example, is made up of the brain and the spinal cord. It functions to act as a control center for the body. It processes information and coordinates activities. The brain specifically is responsible for interpreting sensory information, generating thoughts and emotions, and controlling movements, while the spinal cord transmits signals between the brain and the rest of the body. It also coordinates reflexes. The peripheral nervous system components include the nerves that branch out from the brain and spinal cord and extend to other parts of the body. The function of the PNS is to connect the CNS, the central nervous system, to the limbs and organs, and it's divided into the somatic nervous system and the autonomic nervous system. So the somatic nervous system, its function is to control voluntary movements, and it transmits sensory information to the central nervous system. This includes things like the sensory neurons, also called afferent neurons, and these carry information from sensory receptors to the central nervous system. And then motor neurons, or efferent neurons, and these carry instructions from the central nervous system to the muscles. Now, when it comes to the autonomic nervous system, the ANS, its function is to regulate involuntary bodily functions, such as the heart rate, digestion, respiratory rate. Its components, it's further divided into the sympathetic and parasympathetic nervous system, so further division. The sympathetic nervous system, this function is to prepare your body for a stressful or an emergency situation, the fight or flight response. All right, so what happens is it'll increase your heart rate, dilates pupils, inhibits digestion, while the parasympathetic nervous system, this function is to promote relaxation and recovery, so rest and digest response. So it slows the heart rate, it constricts pupils, it stimulates digestion. So summarizing right now, the functional division of the nervous system: brain and spinal cord processes and coordinates information. Peripheral nervous system, nerves outside of the CNS, they connect the CNS to the rest of the body. It's made up of the somatic nervous system and the autonomic nervous system. Somatic controls voluntary actions, transmits sensory information, while the autonomic nervous system controls involuntary functions. Autonomic is broken down into further divisions: the sympathetic nervous system and parasympathetic. Sympathetic activates the fight or flight. Parasympathetic activates the rest and digest. Hopefully that put everything into perspective. All right, so here we just see the hierarchical breakdown of the central nervous system, brain and spinal cord, from what we saw in the previous slide. Anything new? We can talk about how neurons communicate within this system. All right, so remember that neurons are like the messengers. They're the basic building block for the nervous system. They're specialized cells. They send and receive electrical signals. So these electrical signals within the neurons are used to communicate using these action potentials. And those action potentials travel along that neuron until they get to the synapse. When the signal reaches that end of the neuron, it triggers the release of those chemicals that we call neurotransmitters. These chemicals cross that gap, that small gap. We call that the synapse. Before it gets to the next neuron, and then it passes that signal along. How is this important in understanding the brain and its role in behavior? Well, the brain processes information from your senses, like sight, sound, and touch, and then decides how to respond. So different parts of the brain control different behaviors, such as thinking, moving, feeling. Remember we said cognitive, in this case cognitive, behavioral, and affective. What's the spinal cord's role in all of this? Spinal cord just acts as that transmission, that highway for signals between the brain and the rest of the body. It controls reflexes as well, where you need quick responses to something without the brain having to process it. Automatic responses. And an example for electrical control in this system would be, again, when you touch a hot stove. We touch a lot of hot stoves in psychology, or as an example. So you touch something hot, sensory neurons send a signal to your spinal cord and brain. The brain quickly processes the information, sends a signal back through the motor neurons, back to your hands, and this happens in a split second, and then you just pull your hand back from the hot stove. This is important because you want quick responses. Right? Electrical signals in the central nervous system, they allow you to react quickly to your environment, like pulling your hand away from something that's hot or jumping out of the way of danger. The CNS also helps with coordinated movement, walking, running, playing sports. We said that before. It helps with thoughts and emotions. All this electrical activity is behind your thoughts, memories, emotions, and so forth. Okay. Let's keep going. All right, electrical control of behavior, nervous system. So nerves, sensory neurons, motor neurons, and interneurons. We've kind of mentioned this before. Sensory neurons, so imagine you're holding a hot cup of coffee or a hot cup of chocolate, and your sensory neurons, again, acting like messengers, will sense the heat from the coffee or the cup. The neurons that you have all over your skin and other sense organs, they'll detect something like the heat from the cup. They send signals to your brain and your spinal cord. Interneurons, these are the sensory neurons that connect, right? That's what they're called, interneurons. They're like the middlemen of the nervous system. They receive the messages from the sensory neurons and decide what to do next. So they're found in the brain, spinal cord, and again, they just help process information. The motor neurons, so after it passes the interneurons process the information. The signals go to the motor neurons, and motor neurons are like the workers that get things done. They send signals from the brain to the spinal cord to the muscles, and it tells the muscles to move. All of this happens rather quickly. The body's kind of amazing. So in our example, the motor neurons would tell your hand to pull away from the hot cup of cocoa or the hot cup of coffee if it's too hot. All of us working together to create this complex behavior. All right, reflexes are pretty cool. So let's talk about reflexes. The basics of what a reflex is. So it's fast. It's automatic response to some stimuli. So again, let's go back to the touching something hot. You quickly pull your hand away without even thinking about it. And this quick response is thanks to not just humans, lots of creatures having reflexes. Let's talk about what's called the reflex arc. And this is just the path that reflex takes through your nervous system, and we call it the reflex arc. And here's a little, let me go over how it works, right? Or kind of like a flow chart of how it works. So first you have what's called stimulus detection, and that's, let's say, again, you touched a hot cup of coffee, a hot cup of cocoa. Your sensory neurons in your skin detect the heat. You have a second step, which is signal transmission. This will the sensory neurons send that electrical signal to your spinal cord. The signal travels really fast. It goes through the interneuron processing. So your spinal cord interneurons, they receive the signal from the sensory neurons. But instead of sending this signal all the way to the brain, which would take more time, the interneurons quickly process it and decide to take action immediately. So then it goes into the next step, which is called response command. The interneurons, they'll send a signal to the motor neurons. So it just bypasses the brain and causes you to react right away. And then you end up with an action. The motor neurons send a signal to the muscle in your hand, and it tells them to pull away from that hot object. And this is why reflexes are very, very fast. They're fast because you bypass the brain. The signal goes from sensory neuron to interneuron to the spinal cord, and then back to the motor neuron. It's a really quick response. It's almost instantaneous. Another good example would be the knee-jerk reflex. A common example of this reflex is a knee-jerk. The doctor will actually tap your knee with that really small hammer, that little tiny hammer, and sensory neurons in your knee, they send a signal to the spinal cord. The interneurons process this signal and immediately send a command to your leg muscle, and it causes your leg to kick out quickly, so without it having to go through the brain. It's automatic. It's very, very hard for you to even stop it, knowing that the doctor's going to go ahead and tap you in the knee there. Okay, so why are we studying the peripheral nervous system, and how does it control behavior, or at least electrically? So the peripheral nervous system, again, it's this vast network of highway connections from the brain, spinal cord, to the rest of the body. The two main parts, the sensory and the motor division, control all of this. Within the sensory division, that's the part that's responsible for gathering information from the environment, right? Then it sends it to the CNS. The sensory neurons, like messengers, they detect things like touch, pain, temperature, and other sensations, and they take that information from your skin, muscles, organs, and they send it to the brain and the spinal cord. And then the motor division. I always get like these little images. Motor division, I think of like an automobile, but no. Motor division, right? This is the part that sends commands from the central nervous system to the muscles and organs, and it tells them how to respond. So within that, there's two parts, the somatic nervous system and the autonomic nervous system. Again, somatic just does voluntary movements, like motor neurons, right, that carry signals to skeletal muscles and instruct them to move. And then the autonomic nervous system, these are involuntary actions, and these are for things that you don't consciously control, like your heartbeat, your digestion, and so forth. And again, within that autonomic system, one more time, we're breaking it down into the sympathetic nervous system and the parasympathetic nervous system, right? Sympathetic, we said, was the fight or flight. So example, you're scared, it increases your heart rate, makes you ready to either fight or run away. The parasympathetic nervous system, we said, was rest and digest. And this part calms your body down and helps you relax after a dangerous pass. So it slows your heart rate and helps you with digestion. Right. So these are very important when you're sensing danger, you're trying to process information, you're sending commands, and then you want to take some action, and when you actually want to calm down and relax. All right, sympathetic and nervous system and parasympathetic, let's go into these in a little bit more detail. So the autonomic nervous system, right, that's part of the peripheral nervous system that controls involuntary actions, things that you don't consciously control, like your heartbeat, digestion, breathing, right? It has those two branches, sympathetic and parasympathetic. Sympathetic, fight or flight, prepares the body for action. Your body responds to some emergency. You face something very stressful, it kicks in to help you deal with it. So what happens is you sense some kind of danger. So you're walking in the woods and we see a bear or a skunk. Yeah, skunk is not dangerous, but that would we'd still be under stress. And then, right, you see a bear, and your sensory neurons detect the bear and send this information to the brain. This activates the sympathetic nervous system, and the brain processes the information, activates the sympathetic nervous system. It releases adrenaline. The sympathetic nervous system then signals the adrenal glands to release adrenaline, right? And the adrenal glands are these endocrine glands that sit right on top of the renal glands, right? That's what they're called, adrenal. And they release adrenaline, and that prepares you for your next action. So adrenaline and other signals will cause several changes in your body. So your heart starts racing, either racing to fight or racing to run. You'll get more blood to the muscles. Um, your breathing increases. You start bringing in more oxygen into your muscles, into your body. Muscles get a lot more blood. You have all this. You're preparing for expending a lot of energy, and you're preparing for real quick movement. Things that are non-essential functions like digestion, all that will slow down, so your body can focus on that immediate threat. Whatever you're going to decide to do, whether you're going to run or you're going to fight. The last part is up to you. The parasympathetic nervous system, we said this is rest and digest. This is the part that helps your body calm down. It returns to this relaxed state after some danger's passed away. So how it works is that you sense that safety after the scenarios done. Either you ran away and you ran away from the bear didn't chase you, and you realize you're in a safe predicament, or it was a tiny bear cub and you kicked it or beat it and it ran away and you feel safe now, right? You feel like a big man. But once that threat is gone, the brain recognizes that the danger is past, and what happens is you activate the parasympathetic nervous system. The brain helps you calm down. The nervous system starts sending signals to the body to slow things down. It starts slowing down your heart rate, your breathing starts slowing down, your blood pressure, your blood flow starts returning to normal. It starts actually returning to the non-critical functions like your digestive system, and that starts resuming. Your muscles start relaxing. All of this works together to kind of keep yourself balanced, the sympathetic and parasympathetic nervous system. You can look at other examples, like maybe when you go on a scary ride on a roller coaster, or how you feel right before getting on the roller coaster, and once it takes off, and then once the ride is over. Um, we're not going to do a field trip, but that would be a nice one we could discuss. Okay, let's talk about the autonomic nervous system now in a little bit more detail. Right? So, in biological psychology, the study of the brain and other biological systems influence behavior, thoughts, and emotions. So I'll say behavioral, cognitive, and affective. So what we do in biological psychology is explore the brain and how it communicates with the body through those electrical chemical signals that go everywhere. Everyday activities and nervous system interactions, from waking up in the morning to going to bed at night, everything in between. You have this constant interaction with the sympathetic and parasympathetic nervous system. So in biological psychology, which is the main focus of this chapter, it examines how these systems work together to regulate behavior and maintain balance in the body. When we talked about the sympathetic and parasympathetic, remember these are parts of the autonomic nervous system controlling involuntary bodily functions, heart rate, digestion, respiration. They have opposite effects, but they work together to ensure the body responds appropriately to different situations. So the sympathetic nervous system prepares the body for fight or flight, emergency situations, heart rate increase, dilating pupils, slowing down digestion, parasympathetic, rest or digest. These are things like decreased heart rate, constricting pupils, and stimulating digestion. All of this has to be maintained with something called maintaining all this within like normal parameters is called homeostasis. And homeostasis is that ability of the body to maintain this stable environment. It doesn't mean a static environment like nothing's changing. It just means things fluctuate up and down within a controlled range. Right? So your body's constantly adjusting high or low, but it's normally very, very regulated and periodic, and nothing too out of the norm until you reach one of those situations where it requires it to. And so all of this helping you respond to stress, recovery, and relaxation, and just maintaining everyday balance. Biological psychology gives you that perspective from biology to understand the peripheral nervous system, the somatic nervous system, and how all of that helps us comprehend the brain and how everything works together to affect our behavior. Right? We learn how we deal with stress and how we cope with stress, how we regulate the emotions, our emotional regulation. You might even say, which I don't like the term, emotional intelligence. I don't think that's a discipline in psychology. I actually think it's actually the opposite trait of neuroticism. So, but that's my rant on emotional intelligence. I don't think it's a real discipline. Health and disease, and so forth. Try not to go off on a rant there. Let's talk about the body's chemicals and how they help control behavior within the endocrine system. First, we're going to talk about a gland and a hormone and what are they. Um, the endocrine system first. What is it? We talked about the nervous system. The endocrine system is also another communication system within the body. It's made up of a network of glands that produce and release chemicals called hormones. And these chemicals are also chemical messengers like neurotransmitters. Not like them exactly, but they are chemicals and they are messengers. And these chemicals actually travel through the bloodstream to various organs and tissues, and they influence a lot of things about our physiology, which eventually affects our behavior. So the main components of the endocrine system in general are glands, right? And glands are these specialized organs, and their main function is to secrete hormones. One of the glands is called the pituitary gland. We call this the master gland because it controls other glands. So what it does is it releases hormones that has a direct effect on the body, but it also releases hormones that causes other glands to release their hormones to have effect in the body. So that's what we call it, the master gland. The hypothalamus, we mentioned this before, it's part of the brain that links the nervous system to the endocrine system via that pituitary gland, and it helps regulate body temperature. It helps regulate hunger, thirst, and other things. The thyroid gland. The thyroid gland produces hormones that regulate metabolism, energy levels, and growth. Have you ever heard someone who might say, "Oh, I have hypothyroidism," like HYPO, meaning that mainly they're talking about how their metabolism might be low, their energy levels are low, they're fatigued. Um, Someone with hypothyroidism will have low metabolism. They'll tend to be bigger, as opposed to someone who has hyperthyroidism, who will have just a natural higher metabolic rate, and they tend to be very, very tiny, and they're very, very prone to accidents because they tend to have a lot of energy and they don't sit still. Um, it's just indirectly, right? They just have all this energy, they move around, they don't sit still, and because they move around so much, they're actually very prone to accidents. Uh, so yeah, nothing that the thyroid gland makes you trip or lose, balance or anything like that. It's just that they don't sit still. So, adrenal glands, we talked about these. They sit on top of the renal glands, which are your kidneys. Renal is just another word for kidneys. The adrenal glands sit up there, and they'll produce things like adrenaline, which is epinephrine. They also release cortisol, which is the chemical that causes your body to respond to stress. The pancreas, this produces insulin and glucagon. The main function of the pancreas, besides it's an ancillary organ for digestion, but in the endocrine system, its function is to regulate blood sugar. Right? So, think of diabetes. The gonads do not just refer to testes. Ovaries are gonads, and testes are gonads. These are sex hormones that are produced in the gonads. So estrogen, progesterone if you have ovaries, if you're a woman, or testosterone if you're a male, which influence the sexual development and behavior for both. So we talked about hormones. So what are hormones? I said they're chemical messengers, kind of like neurotransmitters, but these are released by the glands. They travel through the blood. They're not traveling through synapses across neurons. They travel, I would say, great distances, relatively speaking, to neurotransmitters to reach a target. Again, they bind to specific receptors, just like neurotransmitters. So as they go to the blood, they're going to find their target and get attached to where they need to, and they're going to cause a reaction in that cell membrane to do something. So they trigger these responses. So, like for example, if it's adrenaline, that prepares the body for fight or flight. If it's cortisol, it helps manage stress and control blood sugar levels. Insulin, remember we said that regulates blood sugar by allowing cells to take in glucose. So insulin is like a key. I call it a key. It opens up the cells, and sugar can actually get inside the cells and undergo metabolism. Estrogen and testosterone from the gonads, this influences sexual development. It influences reproduction and then certain sexual behaviors. Right? So all of these are influential on behavior. So we think about the nervous system as our control system, but it really isn't. It's more like the infrastructure, as where the hormones tend to really have a strong impact on how we behave and how we respond to either stress, how your mood and your emotions change, to other things physiologically, like how you grow and how you develop. Oh, and then we mentioned your metabolism and your energy. And of course, your sexual behavior. All right, continuing with the endocrine system overview. In this slide, we're going to talk a little bit about the pituitary and the adrenal. I say adrenal just to stress that it's on top of the renal glands. It's pronounced adrenal. And you'll just always hear me mispronounce it on purpose, adrenal, so that you can remember renal. Just a review, endocrine, right? It's made up of those glands, produce hormones, chemical messengers, go to the bloodstream, they reach their target organs, they influence behavior. Pituitary being the master gland. Again, it secretes hormones to activate other glands to secrete hormones, or it also secretes hormones to directly affect organs themselves. Growth hormone is one of them. It stimulates growth. It also stimulates cell reproduction. It influences physical development during childhood, adolescence. You have something else called adrenocorticotropic hormone. So because it says adreno, you can kind of guess that this is produced in the adrenal glands. That stimulates adrenal glands to release cortisol, which is a hormone that helps the body respond to stress. Yeah, I'm sorry, I said adrenocortical, not that it's secreted by the adrenal glands, but it's secreted and affects the adrenal glands. Thyroid stimulating hormone, TSH, also produced by the pituitary gland. This stimulates the thyroid gland to produce thyroid hormones. That regulates your metabolism. So if your metabolism is low, it could be that you have low TSH from the pituitary, or it could be that you have low T hormone, thyroid hormone, that regulates your metabolism. There's something else called prolactin. That's another one produced by the pituitary gland. This is what promotes milk production and breastfeeding. So this affects women and affects their, it also affects their reproductive behavior. We have something called follicle stimulating hormone within the pituitary gland and something called the luteinizing hormone. These regulate reproductive processes. So in women it includes the menstrual cycle, and for men it includes sperm production. Now, the pituitary gland is broken up into anterior and posterior. The posterior specifically produces oxytocin. This is also called the love hormone. You tend to release this if you feel connected to somebody for whatever reason. There was that funny TED Talk. No, it wasn't a TED Talk video. There was the video I think we saw in class talking about bad research articles, and someone was making fun of the love doctor who would cause you to release oxytocin just by giving you a hug. Yeah, that was the funny thing. But oxytocin, it plays a role in social bonding. So also sexual reproduction and during and after childbirth. So it's what causes that bonding with the child. Um, it's also released during sexual activity, so it causes bonding within there as well. Vasopressin is an antidiuretic hormone, ADH. This just helps regulate the water balance in the body. It controls the amount of water that the kidneys will absorb. Okay, and then down to the adrenal glands. These are stress responders, right? They release cortisol being one of them. They release stress hormones. So cortisol is known as the stress hormone that helps the body manage stress. What it'll do is it'll increase blood sugar levels, and it does enhance brain function. It does suppress the immune system. People with high cortisol levels, they tend to gain weight because of this hormone. So you can't be in this condition too often. Uh, the other hormone is called aldosterone. This regulates salt and water balance in the body, and so this helps control blood pressure indirectly. Um, Within the adrenal gland, there's the adrenal cortex and the adrenal medulla. Within the adrenal medulla, I'm sorry, the first kind of hormones were secreted by the adrenal cortex. The adrenal medulla secretes the epinephrine, or adrenaline, right? That causes your body to increase heart rate, get ready for something important. Norepinephrine is also secreted by the adrenal medulla, and this works with adrenaline to increase alertness and readiness to respond to some kind of threat. So I may have mentioned this earlier that there's another chemical that helps you regulate your appetite, and norepinephrine happens to be one of these. So people will take norepinephrine reuptake inhibitors, and those actually also decrease appetite if you don't take one of the other, the serotonin reuptake inhibitors, which are meant for anxiety, but they also cause people not to be as hungry. I guess if you eat because you're stressed, and so if you take that and you're not stressed, you won't eat. So maybe if you're overeating due to stress, um, then this serotonin reuptake inhibitor and norepinephrine reuptake inhibitors, they'll be given to you to help you regulate stress. But if you're also overweight, it'll also help you with the I guess I won't call them side effects, the other symptoms of being stressed, where people stress eat. It makes sense. I'm not sure if, it makes sense. It might be right. That might be the reason why. When we talk about these glands influencing behavior, the pituitary gland affects the growth and development, helps you respond to stress, it affects your reproductive behavior. The adrenal glands are responsible for your fight or flight. They help with your stress and your mood. And that's it for this slide. Wow, we're almost done. It's a super long chapter. Let's do a little overview of the endocrine system. So we started off kind of specific with the organs and specific hormones. Now we're kind of pulling back out a little bit, just a little bit. Again, this endocrine being this network of glands, and the glands secreting hormones, these chemicals going through the bloodstream, and again, in comparison to neurotransmitters, which are these chemical messengers that are going across the synapses of neurons, right? It's a very short distance that they're traveling, and they're traveling extremely fast, where hormones are traveling, relatively speaking, great distances through the blood. And it takes the blood about, let's say one blood cell went through your entire body, it takes about 60 seconds for it to travel through your entire body, for blood flow to go all the way through. So these chemicals, once they get released, or once you take a drug, it's about a minute or less for that, either the drug or this hormone, to get to where it needs to go, or less than. So it's still pretty fast, but not millisecond fast. We talked about the pancreas. That's located behind the stomach, and it's used for regulating blood sugar levels. Remember, the pancreas, other than being part of the endocrine system, it's also an ancillary organ for the digestive system, which we won't talk about here, but just to know that pretty much every organ has its main function. It's part of one system, that's what it's known for, but it also has some indirect effects on other systems. So again, the pancreas being part of the endocrine system and also being related to the digestive system. It has some indirect factors there to help digestion. It releases enzymes and other stuff, right? But the pancreas itself, within the hormones that it releases, insulin and glucagon, and both of those help control the amount of sugar that you have in your blood, which end up affecting the energy levels that you sustain throughout the day. What else? And that's it. The pineal gland. This is a small pea-shaped gland. It's located in the brain. It regulates sleep-wake cycles. I think this is the one that they say it's about the size of a chickpea, or it looks like a chickpea. There was a movie, and they made reference to that. In fact, the guy gets surgery in the movie, and they his soul. I'm sorry, they removed his soul, and his soul was like a chickpea. Sorry, but what they discussed sounded to me like an endocrine gland. Definitely not the pineal gland. So what it does, it has it regulates your sleep-wake cycles. And it does this with the hormone melatonin, and these are produced at night and help you actually fall asleep. So they'll influence behavior by sort of regulating your sleep patterns. So if your sleep patterns are not regulated well, then you tend to be very cranky, not able to focus, and all those other kind of things. So you need good quality sleep, and that's actually regulated by the pineal gland by secreting melatonin. Melatonin is something you can actually buy over the counter as well. They sell tons of it at every pharmacy, every nutrition store sells it. So you can, buy some if you have some hard time sleeping. I personally can't take melatonin. My body seems to fight this artificial melatonin pills. I've taken them, and my body sort of feels like it's that dying episode where it's like you fall asleep, but you wake up horribly within a few seconds. It's like your body fights it really, really bad, and then that keeps me up even harder the rest of the night. We talked about other things called seasonal affective disorder. SAD, I mentioned this. This is kind of like a depression that you get when you're they call it seasonal because you tend to get it when the weather changes and the environment changes. You have less sunlight, and melatonin is actually affected by sunlight. So when they say seasonal, they mean like you're going into fall, and then there's less sunlight, shorter hours of sun, so then that affects your melatonin production, and so you have shorter days. So people tend to get this thing called seasonal affective disorder. They start feeling sort of depressed. It's not something you can just cheer someone out of. It just happens, and it happens at a certain time of the year. You can actually take medication to kind of compensate for this. We talked about the thyroid gland. It's again a butterfly-shaped gland. It's located in the neck, regulates metabolism. The specific hormones that are released by the thyroid gland are thyroxine, T4, another one called triiodothyronine, T3. This works with T4. It regulates metabolism and energy. Now I noticed that it said triiodothyronine because it has iodine in it, and so iodine is actually something that we need in our nutrition. We don't make iodine, so we have to get it outside from something. So have you seen the salt shakers, the Morton salt? The picture with the little girl and she's holding the salt and it's spilling. She's walking through the rain, and it says iodized. It's fortified with iodine, whatever. That's taking salt with iodine is kind of important, or else we won't get it any other way, unless you eat some vegetables that actually have it. But that's one way of getting it into your diet. And all of this, if it's not regulated, will affect your metabolism and your energy, which ends up influencing your behavior. Right? You can feel very, very inactive. It'll affect your cognitive function. You might not be able to think clearly. It'll affect your memory. You can't concentrate. You can't remember things. So underneath the thyroid gland is the parathyroid gland. The parathyroid glands are actually these 4 small glands that are located on the thyroid themselves. They are actually used to regulate calcium levels in the blood, and calcium is very, very important for a lot of membrane potentials and maintaining that potential voltage across the membranes, which actually helps move the electrical signal across the neurons, right? So it's very important to keep that baseline voltage across that membrane so that conduction signal can actually travel. If you don't get calcium from your diet, your body is actually going to get it from the bones. And people who have problems with calcium absorption, they end up having weak bones because the body is actually pulling it from the bones. So your body's going to get it somewhere if it can. If it's not, then you should make sure that you increase it, include it in your diet. And again, all of these things, if you don't feel well, your body physically doesn't feel well, your physiology doesn't feel well, and all down to your biology, your cell it's not doing well. It's just going to affect your overall behavior. Right? So you've heard the term hangry, right? When people are hungry and they get very short with others, that's all related to biological psychology. Let's continue with testes and ovaries, testes in the males and ovaries in females, these sex glands. So the endocrine system, again, produces hormones, and specifically when we talk about the gonads, the testes and the ovaries, the testes are the primary male reproductive organs. They produce sperm and secrete male sex hormones. Hormones from the testes would be testosterone, that's the primary male sex hormone. It plays a crucial role in developing male reproductive tissue, secondary sexual characteristics like facial hair, the deeper voice. Overall, it helps maintain overall male health, specific things that are to males. It does influence male behavior, for example, sexual behavior and libido. Testosterone is key in regulating sexual desire in males. So higher levels generally increase libido. It increases competitiveness. It can also increase aggression, and it's been linked to aggressive behavior and competitiveness, right? Trying to be dominant is dominant male behavior. So all of that will affect your mood, your energy as well. It also affects the density of your muscles and your bones, preparing you for that dominant role, I guess. When we talk about ovaries, the female sex glands, these are the primary female reproductive organs, and they produce eggs, which are called ova. They also secrete the female sex hormones, and the female sex hormones would be estrogen and progesterone. So estrogen is that primary female sex hormone that's crucial for development of female reproductive tissue, secondary sexual characteristics like breast development, widening of the hips, that kind of thing. Regulation of the menstrual cycle. Progesterone, this works with estrogen and it helps regulate the menstrual cycle and it helps maintain pregnancy if a woman gets pregnant. It does have its influence on behavior as well, right? So sexual behavior and libido, progesterone regulates sexual desire for women and it helps with the reproductive behavior in females, causing people to want to reproduce, right? Say it lightly. So this fluctuates monthly during the menstrual cycle, and again, the libido is also affected monthly. I mean, throughout the month. You can see how this affects mood and emotional regulation. When we talk about menstrual cycle and reproduction health, estrogen and progesterone control the menstrual cycle, and all this influences reproductive health behaviors that's related to fertility and ultimately the goal is pregnancy. It's also crucial for bone health in women. So estrogen helps maintain bone density. Low levels, like when a woman reaches menopause, can lead to increased risk of what's called osteoporosis or bone thinning. So the bone just starts thinning out, getting weaker, so that women tend to have more, they're more prone to fractures and breaks in the bone. That's about it. During adolescence and puberty, increases in testosterone for men and estrogen in females. This leads to the development of the secondary sexual characteristics. It also leads to changes in behavior, and it also causes the interest in sexual activities and shifts that social interaction with both males and females. All right, but you have to be exposed to those hormones to actually know how it's going to affect you. That's it. Again, all of this does end up leading to social and emotional behavioral um, changes, right? So you can see how all of this presents itself socially, psychologically, emotionally. Yeah. And this is it. This is the takeaways from chapter section 3.4. I'm not going to read these. You can read these yourself. Just want to get through this. Oh, we got one more slide. And this is the last takeaway, 3.4. The spinal cord. Yeah, we're not going to read all that. And I think we're done. We are